This video here is going to be talking about derivatives of inverse trig functions. Frankly, this is not a super, in my mind, important topic for the AP test, but it is technically on the AP test, so it's good to have mentioned it briefly. And these can be calculated by using inverse function theorems, and then the main reason that we use this is because you can end up rewriting recognizing that something is an inverse trig relationship and do some tricky stuff to simplify things. But like we've talked about before, trig identities are more important that you kind of have them in your brain of, hey, this looks kind of like something that might be a trig identity, and that should clue you in to go look it up if we're talking about the real world outside of the AP test. None of these are super critical to memorize or remember for like practical future tasks. But they are technically on the AP test, so I want to make a passing mention of them. So with these, it's just a bunch of relationships that I'll write down so you've got them in your notes, but honestly, I would not worry too much about these as you prepare for quizzes or the AP test. So the derivatives of each of these inverse trig functions, or if you prefer arcsine, arc cosine, arctangent, the derivative of the inverse sine is 1 over the square root of 1 minus x squared. The derivative of cosine is negative 1 over the square root of 1 minus x squared. And the derivative of inverse tangent is negative, or not negative, it's 1. 1 over 1 plus x squared. And then similarly, we'll make mention of cotangent, cosecant, and secant. Cotangent inverse of x is, and as you can see, I'm referring to my notes because I don't remember them because, as I said, I don't think this is super critical for you to have these memorized. Inverse secant is 1 over the absolute value of x square root of x squared minus 1. And cosecant is x 1 over x square root x squared minus 1. The real reason to know these is actually going to be for our next unit, which again, I don't think it's super important in our next unit. But if you see something, say, of this form, you'll know how to integrate it, how to work backwards from this equation. But we talk about them here because technically you can use the fact that we know derivatives and integrals of, or derivatives of sines, cosines, and tangents to find the inverses of those. It's not important to know how to derive these, how to get them. It's just important to recognize that this is what the derivatives are. If you have any questions, let me know.